Let's get started. We'll begin by installing ChromaDB, which is a vector database. We'll install it using Docker. I won't be explaining Docker itself here. Instructions on how to install it can be found on Docker's official website. From the documentation on the ChromaDB website, we take the command that builds a Docker container for running ChromaDB. In this command, you can see that the -v option is used to mount the data directory containing ChromaDB data into the host's Chroma-data directory. The -p option is also used to expose port 8000, which ChromaDB uses inside the container, allowing access to ChromaDB from the host machine. When we run this command, Docker pulls all the required images, including the ChromaDB image, then builds and starts the container. Let's begin by creating a new directory called reg-mongo-data on the host machine. We will mount this volume to persist our database data. Here is the main command. We run a new container named reg-mongo, mount our local directory to /data/db, and map port 27017 so we can access it externally. Running Docker PS confirms that our MongoDB container is up and running correctly. To test the database, I'll launch MongoDB Compass, a graphical interface for MongoDB. I connect to localhost on the default port 27017. The connection is successful, and we can see the default system databases. Next, we'll import data into MongoDB that we'll use for retrieval-augmented generation. For our dataset, we'll use article comments from the New York Times. The dataset comes from Kaggle, and you'll find a link to it in the video description. We'll create a database called NYTC and a collection named Comments, where all of the dataset records will be stored. We'll import comments from January 2017. And choose the most appropriate data types for each field. Once the import is complete, we end up with 231,449 documents successfully imported into MongoDB. Let's run the script to create embeddings. Embeddings are generated in batches of 100 per request. Let's check the collection to see if the records have been created. To do that, we'll enter the container where ChromaDB is running and execute a command to view the collection. We can see that 1,200 records have already been written to the collection. The embeddings creation process is still in progress. The embeddings generation is complete. We can see that 231,449 embeddings have been created, which matches the number of comment records previously imported for processing into MongoDB. Let's start the server. First, we start the ChromaDB server. Then we start the Node.js API server on localhost port 3000. Let's run a semantic search using search type semantic similarity for the phrase "what rumors about." We can see 5 results returned as specified in the query. We get 5 distances, 5 text entries, and 5 IDs for the most similar documents found by the semantic search. In most of the retrieved documents, we can directly see the word rumors. However, in the first document we don't see the word rumors or any obvious synonyms. At the same time, the phrase in the document effectively explains what rumors are. This shows that semantic search truly understands the meaning, not just the exact words. Now it's time to run the RAG process. RAG is actually a question to a generative AI system that is based on data retrieved in the previous step using semantic search. With semantic search, we find the most semantically similar texts in our text collections and pass them to the LLM for further analysis along with the question we want be answered. We want an answer based on our own data, the New York Times article comments, rather than the LLM's general knowledge. That's why we use semantic search and send the retrieved texts together with our question to the LLM-based generative AI service. Our question is, what commented people about rumors? Now we start the survey and send a request to the RAG endpoint. After about 9 seconds, we receive the response. Let's take the response text separately and reformat it into a more readable form. We can see that the response from the generative AI is more detailed than the output from semantic search alone. At the same time, we can see that our data was actually used. For example, on line 3 is included a quote from a text we saw earlier during semantic search. Additionally, we can see that generative AI is able to correctly understand even poorly phrased questions. The sentence, "What commented people about rumors?" is not well formatted in English, yet the model still understands the intent. This video is a condensed essentials-only overview of how to build a RAG pipeline. If it gains even a bit of popularity, I will make a more detailed version where I walk through and explain the code step by step. For now, you can find the code in the GitHub repository linked in the video description. Thanks for watching. Like and subscribe.